Welcome to STEM Lab, where we discuss preparing students for success in a rapidly changing world. And here's your host, Michael Newsome.
Happy to have you here with us on STEM Lab. Today I'm with my co-host, Dr. Nicole Kreger. Nicole, how are you doing?
I'm doing good, Michael. My pre-calculus class this semester is especially doing nicely, so we've been having some fun classes lately.
Now, this is a virtual class, right?
It is, yes. So yeah, they're coming from all across the state, and they're doing a great job interacting with each other, and they've really been kind of stepping up to the plate of answering questions throughout class. So it feels like we're in person, even though they're all across the state.
Now, Nicole, the last time that you co-hosted this show, I think you brought an art teacher on. And so I'm kind of curious about who you're going to bring today. But before we talk about that, I noticed that you're interested in being very detailed on what's going on in the classroom. You like instructional techniques and that sort of pedagogical slant. Do you know why you have such an interest in that?
I think I've always really cared about teaching, and I think it's interesting to me to see what different techniques kind of work better than others. And, you know, every student has a different method that's going to work better for them. So I think it also keeps me energized as a teacher trying to think about different techniques. And even if it's only something that I'm going to use in a small portion, it might not be that I flip a whole class, but maybe I'm going to flip a segment or something like that. So I like having different ideas to be able to sprinkle through a class.
So what kind of teacher did you bring for us today?
Well, Michael, I brought a math teacher for us today. So our guest today is Dr. Gord Hamilton, and he has a PhD in mathematical biology from the University of Calgary. He is the father to 2 teenagers and the designer of several board games, including Santorini. He's done dozens of professional development and taught students across lots of schools, including students in China, the US, the UK, Ireland, Brazil, and Canada. And as the designer of mathpickle.com, he has invented a few hundred original puzzles for use in the math classroom. And that's what he talked to us today, really, is how he is reinventing mathematics education, especially in elementary schools, using puzzles to teach math.
Wow, our first international guest. Well, let's see what he had to say.
Hi, Gord. Thanks for joining us on STEM Lab today. It's awesome to have you here.
Hi, Nicole.
So, Gord, can we jump in? So you've written a bunch of mathematical puzzles. Can you pick your favorite one and tell our audience about it?
Well, I don't have a favorite one, but I will just start with my favorite one from the last 2 months. And that is one where, okay, I'm going to ask you, you're a really lazy architect and you have to build yourself a room. Okay, just a single room. How many walls, straight walls, do you need to build yourself a room?
4?
Yeah, like you could build a triangle, but of course, you don't see too many triangular rooms out there. So exactly, let's make it 4. Let's make it that we're going to be building these rooms on graph paper. And so you have built yourself a little room, let's call it a 1x1 room on graph paper. You can imagine doing that with 4 walls. How many walls do you need to build 2 rooms?
So I guess I would stick them next to each other so that they share one wall. So if they were 2 separate rooms, it would be 8. But if they share a wall, then I would subtract 1, so it would be 7 walls.
Yeah, that's right. So you can do it with 7 walls. And so this is the general question. I want now you to build not a little house with 2 rooms, but a medium-sized house with 3 rooms. Yeah, so that would, or maybe a bigger house with 4 rooms or 5. So that's my favorite question from the last 2 months. And if you ask me in a month, it'll be a different favorite question.
Well, Gord, I feel like, I in my own classes use some questions like this, and I think probably the fancy term would be like low bar, high ceiling type question. So what exactly is it that you love about that particular question and about the puzzles in general that you write?
So I call that specific puzzle an infinite pickle. And that is because unlike most puzzles, let's say a Sudoku, you have general rules like only 1 digit can go in each box. And you've got specific rules. For example, in this Sudoku, the number 6 is in the top left-hand corner. But infinite pickles, like the puzzle I've just described, only have general rules. And with those general rules, you create an infinite cascade of puzzles, from little baby bear puzzles that are easy to solve, let's say creating 3 rooms of sizes of areas 1, 2, and 3, to mama bear ones that are more complex, to papa bear ones more complex, to like these incredibly difficult ones where you might have 100-room mansion, and I ask you what is the fewest number of walls that you need to use to create that 100-room mansion. And by the way, I don't know the answer these are extremely tough problems, and that's what makes me interested in them. I don't want to be presenting problems that I know the answer to. How boring.
That's so much fun. And it's scary, right, from a teacher point of view, to pose these questions to students that you don't know the answer to. But that's also so much fun because you can tell the students like, well, no, I don't know. You have to figure it out.
I think it's actually fantastically liberating for teachers to not know the answers. And yes, the very first time you do it, absolutely, it can be scary. And maybe some of your students find an answer that's better than you've found. Big deal. It is so liberating then to go into classrooms and to just always go in unprepared. And the night before, instead of practicing, let's find all of the answers to what I'm going to present tomorrow, instead of doing that, you can just relax the night before.
Right. Well, and it models the mathematical process for students so much better, right? Like as mathematicians, we don't know the actual answers. We're searching for them as well.
Yeah, as I put it, I would say most teachers are birds trying to teach bats how to fly because they know the answers. They see the answers, and now they're trying to teach those little kids, the bats, how to fly. Much better not to do that. Much better to be of the same species, to go in there and to try it out with your kids, and even if you have a disaster one day, it makes those other days so much more exciting because the kids know, this could end in disaster. We could end up with no answers today. Like that, it's just so much more interesting to teach mathematics like that.
That really is. So how do you propose a teacher use these questions in their class?
I mentor teachers by going into their classrooms. I show, okay, here's this puzzle, and let's try it out. And I do not come in with rule number 1, rule number 2, rule number 3. I don't do that. I'm used to dealing with elementary schools, and that's especially true in elementary school. You don't want to come in with a list of rules. Instead, you want to come in with an emotional engagement by giving the classroom as a whole, or some specific students, experiences of failure because they don't know the rules. So it's all tongue-in-cheek anyway, but you say, okay, give me a number, give me any number, and for whatever puzzle. And they have no idea why they're giving you a number, but they get ownership of whatever you're putting on the whiteboard. And then you keep on going, and you ask another student, and then you said, you guys failed spectacularly. Yeah, that was a spectacular fail. And that's why, because of this reason here, that's why. And so you remove the stigma of failure from the math classroom by giving experiences of failure in this tongue-in-cheek way. So that's my preferred way to present puzzles in elementary school. And that's my area of specialty.
Okay.
Elementary school.
Do the teachers kind of have that fear when you first start doing this with them?
Yeah. So it's a matter of maybe observing me. Maybe I will mentor failure myself. I do that regularly in the classroom for up to about grade 3, grade 4, maybe even grade 5. Kids can't pick out whenever I'm pretending that I don't know something. So I will fake not knowing, and one of my favorite things to do is that if there's a child in the class that is weak, okay, but one time they get the right answer and that they're really okay, they're happy, I will disagree with them in front of everyone. I say no, actually you're right, and just in those 2 seconds you make them question themselves and then feel even happier that they actually beat me. So that's something that I love to mentor as well.
That's really cute, and what a great way to encourage those students, right? Like you kind of so, oh wait, no, I don't think that's right. Oh wait, you got it right and I didn't.
I fake with that 1 second pause. I do that all the time. Like with most kids, they say something and I look like I'm thinking, is that right? Is that right? Oh yeah, that's right. Okay. I think that's just a really good habit to get into. I never have hands raised in my class with answers because you could imagine that slow, ponderous problem solver, and you ask them a question and they're thinking about it, and around them, 3 kids have their hands raised. That child has already been robbed of full success. So I never have hands raised. I go around each and every child and I point to them and I said, tell me a number, or give me this, or give me that. And often I'm not even looking for thinking. Thinking in front of a whole bunch of kids is difficult. So sometimes I'm just saying, like, what color should I color this? Oh yeah, you're choosing number 6. What color? What color should I choose? So silly things like that, just to remove the stress of doing it publicly.
Well, so your puzzles work great for elementary school students, it sounds like, but these sound like things that I could use with my high school students and could work for college students as well. So is there a limit to the age group of students that your puzzles are tailored for?
Well, I haven't solved any puzzle that I'm introducing. I do not have a good grasp on myself. So for that reason, I feel comfortable going into a graduate level math class and presenting these same puzzles. I will say that for me, especially in elementary school, the purpose of mathematics education is problem solving. And in fact, I would abolish, if I could choose, I would abolish the word mathematics as a subject matter and replace it with problem solving. And then having mathematics as the primary way that we support problem solving and get kids to think rigorously. And this is kind of the medium that we do it in. But it's problem solving, not mathematics, that is the name of the subject matter.
Well, and that would, I think, kind of answer my next question, because my next question would be, as a teacher, we have so much content that we have to cover, which I kind of put in quotes because sometimes trying to get through all the content doesn't mean we actually do a good job of it. So yeah, if we could teach it as 2 separate things, if we had problem solving where we could really focus on those problem solving skills, and then mathematics was this other thing, which was kind of where we needed to get through the content, that could help.
In elementary school, there's really, I don't think there's any need to get into mathematics as a separate subject. In junior high and high school, it becomes increasingly required that you need to build skills, mathematical skills. So it does transition. And so I'll be agnostic about when that transition needs to happen, but it's somewhere in junior high.
Your ideal for the future of STEM education would be, let's teach problem solving in elementary school, not worry about mathematical content, and give students this opportunity to explore and engage and have fun.
And board games are a major part of that, because there is nothing that a parent can do that is better for the math classroom than playing a board game with their child and beating them. And that's because problem solving has never been better than face-to-face at a board game. So this is clearly my message to teachers, is talk to parents and say, I don't want you to do any worksheets with your kids. Forget that. What I do want you to do is to adopt a board game. And I want you to play that board game with your child. And I want you to have a fun social experience. And you guys get together and you decide on a board game that you both enjoy. And if the child has siblings, then yeah, make it a family event, whatever. But that is the homework that I absolutely push, is board games in elementary school over anything else.
And I know that you've written a few board games. Do you think that there are particular board games that are better suited towards problem solving, or is it really just any kind of board game?
There are certainly better quality board games than others, and Board Game Geek is a great place to go to find quality board games. On mathpickle.com, I do recommend, I do have recommendations of some of my favorites, but Board Game Geek is definitely the place to go. If I said Board Game Arena, that was not right. It's Board Game Geek is a great place to go. Board Game Arena is a great place to go to play online versions of these games. So if you want to test them out, that's a good place to test them out.
Gord, you've said that the scientific method, you suggest that the scientific method should really be taught in a math class, not in a science class. Can you talk about that?
Yes. So inductive problem solving, it goes way beyond 2, 4, 6, 8. What comes next, kiddies? No, it goes way beyond that. So the question is, where do we teach inductive problem solving? Where do we teach the scientific method? Do we send kids into the real world and get them to go down to the bottom of the school playground and get their hands dirty in the muck? And you can imagine that might be the answer of many educators. But that's wrong. And that's because the laws of the real world are incredibly complex. And so for kids to get a crisp modeling of the universe, that's just way beyond what they're capable of. And so by far the better venue to learn the scientific method is in a universe that has been designed to be discovered, so that the laws are simple and that they are meant for kids to discover. And that is done in math class. And so you can think of many mathematical objects that are open to inquiry, and that kids can go, I wonder if that's true, and they can experiment. But that's where it should be taught. So that's I think that's a bit ironic for many people, is that the scientific method is best not taught in science class for the first time, but in math class.
So would you suggest that be in the elementary school level as well, kind of getting that in the mix there, and then later on they can see that in science classes?
Absolutely. I do it down to grade 2, grade 1. I've sometimes done it and it's been successful. So kids are totally open to exploring and a lot more difficult things than just 2, 4, 6, 8. What comes next? Like a whole lot more difficult. So they're totally capable of doing it.
What has been the most surprising thing that you've seen elementary school students be able to do in working with your puzzles and kind of opening up their mind in this way?
Well, without a doubt, it was whenever I published The Infinite Pickle earlier this year. In the run-up to that publication, I introduced one of the problems called glue to a bunch of mathematicians and educators, and together we worked on it for 2 hours, about 15, 20 of us. And we got a high score of 26. And I thought, that was pretty tough to get there. And then 3 months later, just as the book is about to enter publication, 3 months later, these 3 grade 5 kids, I introduced the problem to them, and they got 29. And that blew me away. So I was just, oh my goodness. I was so confident that we had got pretty darn close to the best possible result.
Gord, what motivates you as a teacher?
The mathematics is definitely what inspires me. Creating puzzles, creating board games, and being creative in that way, that's the driving force. And then once in a while going in and seeing real kids and making sure that I haven't made pedagogic mistakes or mistakes that, this puzzle's good, but it's not as good as that one. Why is it not as good as that one? And so it's really important for me to keep my pulse on a real world classroom, rather than just sitting at home and designing puzzle after puzzle after puzzle.
What have you found has been the key to a good puzzle, or like a puzzle that turns out to be better than, some other ones?
So some ideas early on in Math Pickle started in 2010. Early on, it was going through the book of Richard Guy, Unsolved Problems in Number Theory, and taking those beautiful, deep, unsolved problems of mathematics and bringing them into the elementary school classroom, putting a veneer of story on them, presenting them in a way that the kids could have a vignette of success here, and then they could, that's a little bit difficult. But I could do that. And so they have another little success. And then to build that up so that some kids see, but that's really difficult. So I like to have that, and that would be one of the common threads in the best problems, is that pedagogically they're really strong because you can differentiate at the snap of your fingers. You don't have to go to your desk and then explain some different rules. No, Sometimes I have, I just do it with extra sheets. And whenever I see these really top kids really fast solve something, then I'm ready with a really tough sheet and I present it and just give it to them. The sheets are not numbered, however. So then later on, a slower student group figures out something. They get a different puzzle sheet. And so I'm all the time trying to obscure the lines of, oh, this group's clearly ahead of everyone. They're on puzzle sheet 10. You guys are only puzzle sheet 5. I mean, I don't say it, but you have to actively go against that. Otherwise, that kind of, it just is too easy for kids to know, and it just diminishes their own experiences of success to see, oh, they're at the puzzle sheet that we did 10 minutes ago. Okay, you don't need that in your class, and those kind of things are subtle, but that's the best kind of puzzle. Ones that you can snap your fingers and you can say, you guys work on the 6x6. Maybe they're really fast, but then these slower kids, you give them a more difficult puzzle. You say, and you talk in a loud enough voice so that these kids hear, and you say, oh, you guys be the first to work on a 7x7. Okay, so that all the time trying to muddy the waters so that kids don't know, oh, this kid is up at this level, this kid's at this level, all the time trying to muddy the waters. You know who's where, but they don't need to know that. So you're actively trying to go against ego and to just play the cards in the opposite direction from ego.
That's awesome. I really love all those like little ways that you're trying to get in there of like, well, this person's not necessarily better than this one. And if somebody takes a little bit longer to solve something than somebody else, that's not a problem. But yeah, sometimes that's hard to get in our classrooms, but important things for students to have down the road. You know, in a job, you're not necessarily going to have to be the fastest person to solve something to be good at your job. So how wonderful. Gord, do you have any last things that you would like to share for us about the future of STEM education, or how we can be best teaching STEM and math in particular to prepare our students for the future?
I'll say one thing to mathematicians, and that is that one thing that you could help with is not pejoratively refer to recreational math as recreational math, because that is dismissive. So much of the mathematics that shines in the classroom, these are pedagogic gems, and we don't need to be using pejoratives like, oh, it's just recreational math. No, it's absolutely brilliant math to learn. And you guys, as mathematicians, if you go back 20, 30, 40 years, you would have loved these problems. That's where they shine. So just be careful whenever you use those terms.
Gord, I'm definitely going to be playing around with more of your puzzles. I've gone down some rabbit holes as I was looking you up, playing around with them. They're a lot of fun. So thank you so much for spending some time with us today.
Take care, Nicole.
Well, Nicole, listening to Gord Hamilton was interesting because I noticed, like several of our other guests on the show, he's really interested in increasing the problem-solving abilities that students have. Now, we have heard art teachers talk about how to do that with art. We've talked about how important it is to introduce physics to students early on, particularly in the applied sense. And now Gord is talking about using puzzles and games at a young age, maybe not even calling it math right away, but it's all about teaching students how to think. What did you hear when you listened to Gord?
Yeah, you know, Michael, the problem solving aspect was definitely one of the key things I took away. And then I took away something that I think he kind of sprinkled out through his talk, and that was these small ways in which we can make differences in our classroom to really engage students. That in math, it's not about getting the answer the fastest. So kind of leveling the playing field for students who might be slower, giving every student in the class the chance to talk, even if they're just giving their favorite color or providing a number. And then I really loved his idea of kind of when a student gave a correct answer, that like pause and thinking about it and then be like, oh yeah, you're right. And allowing the student to like think that or to realize that maybe like Gord had gotten the wrong answer, but the student was able to get it correctly. So sprinkling those small ideas into our class to help our students feel more confident in math, but then also level the playing field.
Well, Nicole, thank you for bringing Dr. Hamilton on the show, and I want to thank all of our listeners out there as well. And remember, until next time,
Keep learning and growing.
You have been listening to STEM Lab, produced in the studios of the South Carolina Governor's School for Science and Mathematics.